Okay, 4.2, solving linear inequalities. So we kind of go off, kind of sideways for a little bit with regards to our factoring parts. That'll come back into play in 4.3. Okay, so solving linear inequality. So inequality is when you have these greater than or equal to signs. Okay, it's inequality because it's not equal to something. Okay, if it was equal to something, it would be an equation. So now we're doing inequality. It's not equal to. It's less than or greater than. Okay, the only difference, so the same as linear equations, except when you multiply or divide by a negative number, you have to reverse the inequality sign. Okay, so that's the only thing. So we're going to solve it as if this was an equal sign. So we'll isolate for the letter. But when you multiply or divide by a negative value, then you have to reverse the sign. Okay, so first one. So we are going to cancel out the negative 4 or bring it to the other side. So we add 4. So we end up having 3x less than 11 plus 4 is 15. And then we're going to divide by 3. And we get an answer of x is less than 15. Sorry, less than 5. Okay, so if you had to put this on a number line, remember, so x is less than 5, so this is 0, say 5 is here, so it'd be everything open circle, everything less than 5. Okay, and if you want to check, so plug in a number in here to see if it's less than 5. Okay, so all the values are less than 5, sorry. So you can plug in any number less than 5. So if you plug in 0, see if it's less than 11. So 3 times 0 is 0, minus 4. Negative 4 is less than 11. Sorry, there was a couple things. Solve them and then express your solutions in set and interval notation. Okay, so set notation is just our regular like domain. So our XER such that x is less than 5. Okay, that would be our set notation. And an interval notation is we have our brackets, so our lowest value and our highest value. So lowest value here, if this keeps going, then it's going to be negative infinity. We'll have a open bracket for that, or a curved bracket. And our highest value will be 5. But it's not including 5, so round brackets. Okay, so negative infinity to 5. Okay, let's do the next one. Okay, so we're going to cancel out the 3x, bring it to this side, so plus 3x on both sides. So we get 8x. 8x is greater than or equal to 4. Divide by 8. X is greater than or equal to 0.5. Okay, on a number line, imagine 0, so everything's greater than or equal to 0.5. So it'd be something going this way. This would be 0.5. So set notation, it's just this, but include the XER. XER such that x is greater than or equal to 0.5. You guys can see that. Okay, and then in interval notation, so our lowest value to our highest value. So our lowest value is 0.5, so 0.5, and our highest value is positive infinity. And anytime we have infinity, we do the curved bracket. Okay, so set notation is here, and interval notations are these. Okay, let's get to, I think it's the last question. Okay, third one, 35 minus 2x. Okay, so isolate for x, we're going to subtract the 35 from both sides. So we have negative 2x greater than or equal to 20 minus 35, which is negative 15. Now we're going to divide by negative 2. Since we divided by a negative value, we change this sign. So it'll be less than or equal to now 7.5. Okay, so set notation, XER such that x is less than or equal to 7.5. Interval notation, so if you want to do the line again, less than or equal to 7.5. So our lowest value is negative infinity. Our highest value is 7.5. It includes 7.5, so we have our bracket. You guys can see that. Okay, now our last one. Solve the following inequality algebraically. Illustrate your solution on a number line. So we've been doing that already. Okay, so here this one has two inequalities here, so it looks kind of weird. So we're just going to zoom in here. So we have negative 1 less than or equal to negative 3 bracket x plus 2 greater than or equal to negative 1 and less than or equal to positive 9. Okay, so we have two inequalities here. So we're still going to do the same process where we want to have our x's, we still want to isolate for x here. Okay, so first one. So we're going to expand inside of the brackets first. Let me see if I get this glare out of here. Let me scroll up. Okay, so we're going to expand first inside of the bracket. So negative 3 times x and negative 3 times 2. So negative 1 less than or equal to negative 3x minus 6 minus 2x less than or equal to 9. Okay, now we're going to simplify inside the brackets with our x's. So negative 3x minus 2x is negative 5x minus 6. Again, we're still going to isolate for x, so that means we're going to get rid of our 6 now. Okay, so if you had your equation like this, you have your negative 6, so to cancel out, you would add 6 on both sides. Likewise, if you had just this part of the inequality, you would add 6 here to bring it to the other side. So what we do when we have 2 is we do add 6 to both. So add 6 to the 9, and we add 6 to the negative 1, so it goes to both of them. So now we have positive 5, negative 5x, less than or equal to 15. Okay, so negative 5x is greater than or equal to 5, but less than or equal to 15. Lastly, we have to get rid of the negative 5. So we are going to divide by negative 5, but we're going to do that to all of them. This crosses off. Since we're dividing by a negative, we're also going to change the operation. So we end up getting negative 1, x, and negative 3. So x is larger than or equal to negative 3, but less than or equal to positive 1. So on a number line, we go from negative 1 to negative 3. So we have from here to here. And that would be the full answer. Okay? It doesn't say anything about set notation or anything. Interval notation would be from -3 to -1, and your set notation would be just as it is. Okay, homework is here at the bottom, page 213, 2.3, 4AC, 5DE, 6AC, 7AC, and 12.